Good afternoon now, 12 o'clock. Right, my name's Jason, and I got a Raspberry Pi when they first came out. The sorts of things that I did was mainly the software, which most people kind of start with, like learning how to program with it and making it do kind of what you tell it, essentially. But I've also got an interest in the hardware side, so electronics, and kind of making real-world stuff happen. So when the Raspberry Pi came along, there was the GPIO headers, and it was perfect to get started. So then a few extras came along, like LCD screens, which were perfect. So wrote a tutorial again. People started with LCD screens, making binary clocks on assorted hardware. Time might be right. But one of my biggest kind of interests is robots. So that's what I've come today. So essentially get you started on and show that it's not that hard to make your own robot. So using the Raspberry Pi as a platform and a few extra parts such as batteries, motors, chassis, you can pretty much get a robot to move. So with that you can put all the parts together, add a few wires, write a bit of code to get it going, and you can have something that maybe just as tidy as that to move. So this is a guide that I wrote for Linux user and developer, which will get you started on to make a robot. Pretty much starting from scratch. So you've got the breadboard, wires, driver chip, and everything else that you need. So the important thing is, when you're playing with motors, is to not connect them directly to GPIO pins, because the motors will pull too much current and there is not enough protection on the Pi itself, because I don't have one to hand. The little black ARM chip can't supply, well, it can supply up to about 20 milliamps. Motors, if they stall, can take amps. So don't do that. But what you do need is a driver chip. The simplest and cheapest is called a Darlington array, or ULN 2003. Will let you control up to 7 motors on that one chip, or there's a ULN 2004 which will let you do 8 motors. But this one's a lot cheaper. It only costs about 50p. Pop in the breadboard, a few wires, and you can make a motor turn. But it's only one direction, so you can make it turn one way, which is perfect if you want to, say, turn a fan on, but not so good if you want to make a robot move forwards and backwards. So with that, you can take it up to 50 volts, wouldn't recommend it, and it only needs one GPIO pin, so you turn the pin on, same as you would an LED, and you can start the motor going. The ones that you want to start playing with is this one with the L293D. That one little chip, exactly the same size as the ULN 2003, will let you control 2 motors. So you can control, so if you've got something which will have its own steering, you can control them individually. And you can also use PMW, there's PWM, which is pulse width modulation, and you can vary the speed. Same as if you were doing an LED, you can vary the brightness. Works exactly the same. And it will give you forwards and backwards, because it's known as a half bridge. So you send current one way to one pin, and it will start spinning. Flip the voltage, and it will start spinning the other way. And they can take up to 36 volts. Again, I wouldn't go that high. 12 volts is a good motor for it. But if you do want to do that, you can actually solder them on top of each other, and be able to control a lot more power that way. And it requires 3 GPIO pins per motor, but it's a little bit more expensive. So, not as cheap as the other one, but it's good to get started. Or if you get into full kind of hardcore robotics, you want something a bit bigger, which is this, which works exactly the same, but it will let you do up to 2 amps per motor. So it's perfect for big remote control cars, boats, kind of any large motor, so big fan. But that's even more expensive. So they're the basics what you need. So just literally just that, Raspberry Pi, motors and a battery. That will get you something going. There's many guides on how to wire these up. So you just search the chip name L293D and you'll find wiring guides like this one, which shows you connected directly to the GPIO pins themselves. So all you do is use Python, Java if you're into that, or any language that you like to control the pins. Just turn them on, turn them off, and motors to spin. Nearly handy one. And that's just one of them. But you can also get, so if you're not into the wiring, you can also get driver boards, which will sit on top of the Pi itself, or will connect via USB or some other means, which will do all the hard work for you, so you don't have to worry about wiring. So if you're kind of like me, making them a lot more portable, it becomes a hassle if one wire pops out and you don't notice, and it just stops working and it becomes a headache. But a lot of them will perform other functions as well as. So a good example is the Pi face. Anyone got the Pi face? Yeah. That will let you switch motors on and control them via software exactly the same. The very first one that came out was Simon Monk's Raspberry Robot board, which will let you control 2 motors and sort the power supply out for you as well. Or there's one that I've actually developed myself, had a Kickstarter to get these funded, which will sit on top of the Pi, handle your power functions, and controls 2 motors, 2 servos, inputs and outputs, which is what you need to get something moving. So if you want to connect some outputs such as sensors, turn lights on and such, whilst on the Raspberry Pi itself, that will handle that for you. So my board, nice and simple, will sit on top of the Raspberry Pi, so it will go on top of your GPIO pins. There's a picture of it, very successful. Only wanted 1,500 to get them started, and that was 7,700. Yeah, so that will let you cut a lot of this out. Because if you were going to do them with parts yourself, which is very fun, but will end up looking like spaghetti junction. So if the wire pops out there, it's going to be a nightmare to find it. So you can cut from that down to that to do the same thing. So with this, you can plug in just a set of standard AA batteries, which will power the Pi and the motors, as well as servos, outputs, and everything else. So you can just pop in your power, press the button, and it will turn on. But it will also, if you shut the Pi down, turn itself off. So it's perfect if you want to kind of give it its own power control. So as long as you've got somewhere to switch it back on, or if the battery goes, it can turn off. And it will also handle restarting as well, so it won't switch itself off if you restart the Raspberry Pi. And it can be programmed in any language, so my favourite is Python, but you can also use Scratch, so it's also got Scratch support, so you can just add the blocks of code, and you can make one of these move and read the sensors, so if it bumps into something, you can make it move out of the way. The videos works. That one. So this is those. So that's the actual board itself on top of a robot for someone in China. So he shows the basic functions, so pressing the power button to switch on. Obviously the Raspberry Pi takes a bit of time to start up. He'll also show them logging in. gets there. But it's got a robot arm attached to the front. So with that, you can control the robot arm, make it go up and down, grip things, and on top of the Raspberry Pi, that will move itself around. So on this one, he shows controlling the functions of the motor, the robot arm, as well as turning the Pi. So again, switching on. But he's also created a web front to it. So with the functions forwards, backwards, left, right, open, close, along with the Pi camera. So it doesn't look as good on the computer, but if you open it up on a mobile phone, you can control it with your phone. So the video goes on for about 8 minutes, but he's picking up a little ring. And then drops it, picks up.
Is the camera on the arm?
Sorry?
Is the camera on the arm?
Yeah.
Yeah.
So with that you can drop it into a bottle. But that's just one of the things that you can make with this board. But some of the other designs that I've got, so obviously I've created my own robots, you can use any old toys. So one of the ones that appeals to the older audience members is if anyone remembers the Real Robot series. You can pick them up at car boot sales quite cheap. Or if, like me, you bought all the parts and never actually made it, it comes a perfect chassis because it's already got its own motors, line follower, replacement caster, but it's big enough to mount anything you want. So with this one I have a laser mounted on the front, which keeps breaking off. So you can actually play a laser target with that one, which is actually demonstrated here. So with that you can run it around the floor, and it's all controlled from an old joystick as well. So with the laser and a homemade target, you can essentially make your own little target. So I'll have these working afterwards if anyone wants to go and see them going. But we've done some blue tap for that, I'll get the laser going. But this one's a nice and easy one to use, so just add power. I'll hit the microphone. Switch it on. And we'll wait for the Pi to boot. So with that you can reuse old toys such as Kinects, Lego. So I've got Lego as well. And as long as it's got a motor or something that you can control, you can have something that will move, run around. And this one's actually got a switch just underneath, just to make it easier. So you can just press the power button and it'll start walking. And that's all controlled from just the standard AA batteries. So luckily I've got 2 young boys, so they break a lot of things. So Lego, an old Wii nunchuck, and the nunchuck you can connect directly into the Raspberry Pi itself, so that you don't need to perform any modification at all. Just a small bit of Python. On the next page. When it starts up. So you're not just limited to the motors, got a servo on the front. Depending on how you build it, you can have a Pi camera, which you can have it stream your live stream as it drives around. So with that, you can use a Wii nunchuck to control, well, in this case, a car. Have a horn, and even some lights on the front. So with that, you can have it. Not very good over here. So you can have any means that you want. So using the old joystick, with this one I've got it connected to a Raspberry Pi, and that one will communicate over Wi-Fi and control that one, so you can be fully portable. But as it goes over the network, you can also have it controlled over the internet as well, which is great fun, because you have a robot sat in the middle of your floor, controlled from 200 miles away, which I've done before. So I've come to kind of demonstrate it's not as hard as it looks. Obviously with add-on boards it makes it a lot easier if you're not into the electronics, or if you do like the challenge of plugging wires. It's definitely a good first step to go. And so I'll have these demonstrating later on if I can find a space to sit down, as we're quite busy today. But if you've got any questions, you can come find me at the end and